Welcome to today's Customer Academy Live webcast titled Bring the Cloud Down to Earth. It is now my pleasure to introduce today's host, John Kolesky, General Manager, Cloud Solutions with Fujitsu, Australia. John, you have the floor.
Lovely. Thanks very much, Chris. Appreciate the introduction there. I'd like to welcome everyone today to the call. Today's session is part of a series of hybrid cloud webinars that Fujitsu and Microsoft have been running over the past few weeks around the globe. And we have several well-credentialed presenters, which I'd like to introduce now. I'll be introducing James Staton in a minute. He's Vice President and Principal Analyst at Forrester Research. We've got Nick Ward, Windows Azure Platform Specialist at Microsoft Australia. And from Fujitsu, we've got Chris Gaskin, who's a Solution Director, and Ken Herman, who's a Solution Manager for Cloud, both at Fujitsu Australia. As Chris commented earlier, we'd like to leave questions for the end, but please don't hesitate to use the Q&A tab on the top right-hand side of your screen if you've got any questions, and they'll come up on our screen here in Sydney, and we will make a note of them and ask them at the end. Can I now introduce James Staton, please?
Great. Thanks so much, John, and thanks everyone for joining us here today. I want to share with you what is going on with the enterprise today around cloud computing. And anytime we talk about an enterprise cloud opportunity, we have to realize that not everyone is really acting heavily in the cloud yet. All enterprises tend to take a conservative approach with their strategies. There may be some low-hanging fruit, simple applications that you're putting in the cloud today, but to really make it core to your organization is a hard thing. One of the challenges that we run into more than anything else is cloud washing. Cloud washing is rampant in the industry, where virtualization is called cloud, hosting is called cloud, co-location even is called cloud. And that creates a significant amount of confusion, especially when cloud services deliver a very differentiated and very clearly separate value proposition. So this is Forrester's official definition of cloud, and I won't read it to you, but I'll explain why we chose the words we did. Anytime you're dealing with a true cloud computing service, that service is going to be highly standardized and highly automated, because the goal of a cloud service is to deliver the same service capability to all customers in exactly the same way, usually in a multi-tenant fashion that allows multiple customers to get the same value from it, activate it rapidly, activate it on their own, and then ultimately only have to pay for the portion of that service that they actually consume on a regular basis. Now, when you look at that in comparison to all the other deployment options that you have available to you, cloud is only a portion of what you will be deploying to and you are deploying to today. And that portion has some very unique characteristics. So if you look at this spectrum here of red at one end of the equation and blue on the other, there's a significant amount of characteristics that differ from the traditional side to the cloud side, and not all of your applications will necessarily fit in a full cloud environment. As a result, not everything is cloud, and long term, not everything will be running in the cloud. There will still be applications, services inside of your company that require their own dedicated hardware, may need to be in their own data center, isolated from other resources. Others you may be able to virtualize, but they're not ready to be put on a multi-tenant platform. Then there will be a series of additional applications that will be cloud capable, where they can live on a commodity, standardized environment that's highly automated and can be supported in a multi-tenant fashion. So when you're thinking about your cloud strategy, you want to have this full spectrum in mind. Some applications will make sense to move to the cloud, but a whole lot will not. Part of the reason you will not move a lot to the cloud is the significant concerns that exist around the security of cloud services. Nearly all public cloud services are multi-tenant, which means that if you have a concern about a competitor of yours being in the same cloud as you should assume that that is the case. That allows you to set the appropriate mindset around the use of the cloud. Now, the reality of cloud security is that while there's a high degree of concern around it, most public clouds are actually more secure than the average enterprise. But there's a culture and there's a psychology around security inside of our enterprises that makes them very nervous about trusting outside parties to deliver the same degree of security that they do, especially when you realize that in the event that there's a breach or a legal concern has been arisen because of security, the CISO inside your enterprise is still the guy whose feet are at the fire. As a result, when you're thinking about your cloud strategy, you want to think about using the cloud to optimize your overall portfolio, not to move everything there, but to move what's appropriate. And so what we see the largest enterprises doing today is looking at the different outsourcing options that are there and really placing the right applications against the right implementation. A quick example of that is that we see a lot of SAP ERP systems continue to sit in their own dedicated resources, whereas a collection of applications that mostly have a static footprint but can be virtualized makes sense to put into a virtual hosting environment. And that's what most of us have done with VMware inside of our enterprise organizations today. What do you put in the cloud then? You put applications in the cloud that are commodity and have elasticity or have transiency associated with them. In other words, applications that can live on a standardized platform and can activate the economics of that platform. A lot of your web applications, mobile applications, SOA class of applications are a perfect fit for this environment because of their elastic scalability. They scale up when there's heavy traffic that needs to be dealt with, and they scale right back down when that traffic dissipates. Now, when we talk about private clouds, you can certainly build and set up a private cloud inside of your own environment. But we're finding that most enterprises actually don't have the experience and maturity in their operational procedures to truly deliver a fully multi-tenant, highly automated, highly standardized, and self-service offering from within their data center. Well, as you can see here on this site, that there are some degrees of use of public cloud. The most common answer that we see customers say when it comes to private is either hosted private or a hybrid model, where they recognize that there is still some unique value to the public cloud, and therefore their private cloud strategy has to be in parallel with that rather than an alternative to it. When you then play out the total picture of outsourcing options that are available to you, including the public cloud, and then internal options, physical hardware deployments that you have today, a static virtualization environment that you have today, and then that internal private cloud, you end up with essentially 6 basic environments where any application can be deployed. On one side of the equation, the things that happen inside of your data center are deployments where you are specifically saying, I can commit capital expenditure dollars against these deployments. When you look at the other side of the solution here, this is where you're saying, I'm going to outsource because I'd rather spend operating expense against these applications. And when I go out to the public cloud, I want what the CFO sees out of cloud value, flexible operating expenses that scale up and down in line with our business cycles. Now, when you look at this environment, now it's much more complex than what you may have today with everything sitting in the same data center. You may have a few things outsourced, but you probably don't have this broad of a spread. When you have this kind of a broad spread, how do you actually make this simple? You make it simple by laying on top of it a consistent mechanism for capturing the needs and demands from the business when they want to deploy something new, a workload management system that can act on the decisions and the criteria needed for those applications and say where they should be deployed in this environment, and then through that workload management, ensure that you put the agent, the configuration details, the encryption, and other capabilities that may be required to meet your governance, regulatory, and compliance needs for the applications you're deploying into this environment. So some final thoughts on your overall strategy. The first thing to think about is, in my first phase of a cloud strategy, I need to pick up applications that have elasticity and transiency, that are built in a web services or SOA fashion. And I want to deploy those out based on new application fit with the cloud. That should be your phase 1 cloud adoption and implementation. You do want to think about security but security is actually different in the cloud. We call it an uneven handshake, where the service provider provides the base security that is standard in their cloud service. And if that level of security is not sufficient for the application that you're deploying, then your organization needs to fill the operational gap. In other words, you have to reach further across the table to reach the SLA that you're seeking from the cloud. And then finally, recognize that not everything is going to move to the cloud. Your pace of adoption will vary from company to company. And so you should be thinking about, how do I go with more of a hybrid strategy, where I combine things inside my data center, traditional outsourcing, which still has continued value, as well as cloud platforms and cloud services. So with that, I'm now going to hand off to Nick. Nick?
Wonderful. Thanks very much for that, James. So I'm going to talk for the next few minutes about a variety of different cloud models, and I'd like you to think about these models in context of your own strategy and your own organization and what might make the most sense for you moving forward, keeping in mind that it won't be a one-size-fits-all answer, both from organization to organization, but indeed within your own organization. Different implementations of these models will make sense at different times. If we think about the transformation that's currently undergoing towards cloud computing, there are a couple of characteristics that underlie these models. We're moving to a pooled resources environment where the computing is shared across multiple different applications, potentially with other organizations outside of yours. As James mentioned before, it's self-service. It's something that you can provision for yourself, scale up and down for yourself as you need it, because it is elastic. You can allocate more computing resources or less computing resources as you need as your workloads change. And it is usage-based. So the system is metered and you're presented with a bill based on how much you actually use of the service. These characteristics define three key differences about the way cloud computing works. One is the economics, and James commented that you're moving to an operational expenditure model with this environment, but you're also leveraging a very, very large economic efficiency by moving to these extremely large, very homogenized data centers that run extraordinarily efficiently. You're also getting a lot of agility. So you have the ability to start and stop applications very quickly. Innovation can happen a lot faster because much lower setup costs, much lower time to get something delivered. And it also allows you to focus where you can best deliver change for your organization, whether that's in the application or wherever that might be, rather than focusing on the commoditized platform that your system is running on. So if we think about those different models that are being moved to in just another layer of detail, as James mentioned, physical, virtual, and cloud are three models that are being moved towards. But even within cloud, there are a variety of different subtypes: infrastructure as a service, platform as a service, and software as a service. And I'll talk about these in a little bit more detail as to what they mean. In a traditional on-premise environment, you're responsible for managing everything to do with your computing system, from the applications and the data down through the runtime middleware operating system, right through to the virtualization and then through to the hardware itself. In a cloud model, you're moving some of that responsibility from yourselves to your cloud vendor. So in the case of infrastructure as a service, you're moving the responsibility for virtualization, servers, storage, and networking to your cloud vendor. But you're still maintaining control and you still have responsibility for applications, data, the runtime, the middleware, and the operating system. Compare that to platform as a service, where all of the software plumbing, as well as all of the hardware plumbing, is run by the cloud vendor, and you simply focus on what are your applications and what data do your applications need to run. And then finally, software as a service, where the entire stack is managed by your cloud vendor, and it's ready for end users to log in. Perhaps a little bit of configuration required, but that's about it. The software is ready to go, provided directly as a service by your vendor. And so there are some trade-offs here. In the on-premise model and towards the left of the screen, you've got a lot more control. You can individually customize each component of the stack here. As you move to the right of the screen, you have less control. Things are provided in a more commoditized, more standardized way, but you also have the trade-off that generally things are a lot more cost-effective, a lot cheaper, as well as being a lot more agile in this space than it is on the left. So again, different systems that you have will call for different trade-offs to be made. So all of these models may well be applicable inside your organization. If we think about the application usage patterns that your systems have and how that translates into appropriateness for cloud, if we think about a predictable bursting model. So you've got an application and you know that there are particular times of the day or particular times of the week or even particular times of the month or year that the system is under a lot more stress than at other times. So the usage goes up and down. In this environment, there is typically a cost associated with your server and software that you have to provision to cater for the peak. If this is an important application and you want it to perform at the peak, then you have to provision something which is slightly over what the peak is for that application. Of course, this means that there is an area of underutilization for this particular type of application pattern, times when the server and software that you've implemented is simply not being used, or at least not being used to capacity. So it's essentially sitting there as somewhat of wasted resource. This predictable bursting pattern is matched by a couple of other patterns. Unpredictable bursting. So the application type that sits there doing its day-to-day workload and then without warning shoots up. Maybe an emergency happens that the application needs to respond to. Some workload comes along that can't be predicted that requires a lot more computing power than traditionally the application requires. Again, you have a lot of server and software sitting there idle while it's on its base workload. Something that's growing fast, an application that's growing fast in its usage, you typically have to provision server and software ahead of the curve. So you've constantly got this area of underutilization as the application's growing. And then one more application pattern is the on and off pattern. You've got an application that is used periodically, but in between that time it's simply turned off and not being used. So of course we can see in each of these different types of application patterns there's an element of underutilization, server and software environments that are not being used. Compare that to an application that has a stable high volume. You can provision your server and software to meet that high volume, and away it goes quite comfortably. You have very little wastage in that model. However, if you take a number of these different environments and add them together, the problem increasingly adds to itself. So as you add applications together, you have to provision more and more server and software, and the amount of wastage actually increases as you add additional applications. Now, some level of private cloud type approach can mitigate some of this, but typically an organization doesn't have enough variability in its workloads to really be able to lower the server and software cost just looking at their own workloads inside your organization. So compare that to a cloud model that allows you to provision the amount of server and software that you need as your applications move and change and burst and drop and so forth. So you can move that up and down dynamically. So across your application portfolio, that gives you quite a significant area that you can achieve by moving to a cloud-based model. So these predictable bursting, unpredictable bursting, growing fast, and on and off patterns generally make a lot of sense in a cloud scenario. Okay, and if we can advance to the next slide, please.
we are currently showing Cloud Optimize Your Business.
Okay, just connecting in again and advancing to the next slide. So there are a variety of workloads summarizing that detail that makes sense to move into a cloud-type environment. Rapidly incubating new ideas and innovation makes a lot of sense in the cloud. Applications that have a variability of usage pattern, needing to scale them up, needing to scale them down, either at a high frequency or relatively infrequently, makes sense in the cloud. Development and testing workloads can make a lot of sense in the cloud. Development and testing platforms are typically environments that you need to provision and scale up and scale down very quickly. Disaster recovery, your classic on-off pattern. Doesn't tend to be used particularly frequently, but when it is used, it needs to scale very, very quickly. And shared identity, where you need to share identities potentially amongst different organizations or out to your customers and work together on the same application. The last three there can be particularly good examples for a hybrid cloud approach, where some of it is in a public cloud scenario and some of it is in a more dedicated hosting environment or even an onshore cloud environment or perhaps even a virtualized environment. So Microsoft and Fujitsu have teamed together to simplify your adoption of cloud. Windows Azure, which is the product that I focus on, is provided in a number of key locations in North America, Asia, and Europe. Fujitsu brings over 100 more data center locations around the world, a lot of professional services consultants to support these capabilities, full IT services, strong local footprint, certainly including here in Australia, and also provides a data center running the Windows Azure cloud in Japan, and also provides an integrated cloud model directly with the Windows Azure platform. So there's a lot of value, I think, that can be brought by the partnership between Microsoft and Fujitsu. And so with that, I'd like to hand over to Ken for the next section. Ken, over to you.
Great. Thanks for that, Nick. Good morning, everyone. I'll be here to just talk very briefly about some of the tools available to assist you in moving to the cloud. So it's very rare for any company to have the ability to move 100% of their infrastructure and applications to the cloud. So there's always going to be a requirement for some level of integration between cloud and on-premise resources or between clouds from other vendors. To meet this requirement, Fujitsu, in conjunction with Microsoft, have developed a solution for hybrid cloud services. These services enable integration of on-premise workloads and data with cloud workloads. So the solution consists of a set of professional services. This will help provide guidance on applications and workloads that are going to be suitable for a hybrid solution. We also have a set of reference architectures to help with the best practice design of hybrid solutions between Azure, the Fujitsu clouds, and also your on-premise infrastructure. And there's also integrated operations and management, and this includes single service desk and single billing. So there's only one operator for customers to deal with. So what problems does a hybrid solution solve? Well, the main one that's already been mentioned is that of data residency and security. And many customers would like or are required to keep their data onshore. A hybrid cloud allows your customers to do this, but still leverage the benefits of Azure for compute resources, whether it be for batch processing or video and image processing or some other type of workload. So the customer is always going to retain full control of their workloads and data, and this makes it easy to change their future deployment options. For example, moving to another cloud vendor or relocating data from an on-premise location to an onshore cloud or an onshore data center. The Fujitsu Hybrid Cloud Services reduces your commercial complexity of hybrids by providing a single management entity, and this gives you the single support desk, the single billing, and single engagement models. So now I want to move on to some of the tools that can assist you in moving to the cloud. For those lucky enough to be undertaking greenfield development of Azure applications, or even those who are performing a complete rebuild of a legacy application, the Velocity tool can help reduce development time and also reduce your project risk. Using Velocity, Fujitsu customers have experienced project cost and time savings of up to 60%. So, what is Velocity? Velocity is a software factory developed and owned by Fujitsu, and it extends Visual Studio to provide a graphical modeling tool for Azure applications. It's very similar to Microsoft's Patterns and Practices Group's Web Services Software Factory and the Web Client Software Factory. Velocity allows you to generate runnable code that's ready for deployment to Azure, and also provides full documentation of your solutions. This allows architects and developers to concentrate solely on refining the business logic and functional aspects of the application rather than writing the underlying plumbing code. This is an image of the design service for Velocity, and most architects and developers will be very familiar with its use. Architects simply drag and drop objects onto the design surface and configure them with the necessary properties. Velocity can then validate the design and notify the developer and the architect of any errors or warnings. Once the design is complete, the source code can then be auto-generated. So the generation of a Velocity application will produce complete code for an ASP MVC application, and this will be ready for build and deployment. Any changes to the data structures are also updated automatically. And finally, Velocity will generate the full documentation and diagrams. So let's talk briefly about getting your data onto SQL Azure. It's quite common for customers to move their databases from on-premise location to SQL Azure to realize the benefits of high availability and reduced costs, or because they may be hosting their data-dependent web applications already in Azure. So a common requirement that we've seen is for the migration of Microsoft Access databases to SQL Azure. And with Access being fundamentally different from SQL Server and SQL Azure, a manual migration is usually very complex and quite time-consuming. So Fujitsu's solution to simplify the migration is based on one Nimbus to SQL Azure, which is the only majority automated solution to migrate Access applications from JET to SQL Azure without altering the Access application itself. The SQL Azure tool is unique by the fact that it migrates all of the Access objects, apart from the user interface, from the client side to the server side, and this produces a true server-based SQL application with a thin Access front end. The Access front end can at a later date be replaced with a web interface if required, but by initially leaving the Access user interface in place, no retraining of your end users is required. So there's three parts to this offering. The first is a network crawler to find Access databases across your network. So this tool provides a report on all the Access databases found on accessible network locations, their level of complexity, and when they were last accessed. This enables the selection of candidate databases for migration, as well as those that may be archived. The second is analysis mode, and this allows us to scan in detail the candidate databases. The results of the scan can help to determine a very accurate estimate of the migration work required on any expected issues that relate to the move. And finally, it's the migration mode, and this executes the actual migration and conversion of all the Access objects, including all the tables, queries, macros, data, all across to SQL Server and SQL Azure. Any non-migratable items identified in the analysis phase can be later moved manually. And typically this tool can auto-migrate a minimum of 95% of the objects without any manual intervention. And there will be a brief demo of the solution later. Now on to tools that can assist with the operations and management of Azure. So App Region is a Fujitsu service and a tool that enhances Windows Azure by automating many of the operational functions and providing additional management functionality. A few of the key features of App Region are that you can create auto-scale schedules for Azure roles. For example, App Region can automatically start new Azure roles in the morning, deploy any application-specific features, and then perform any startup operations for those roles. Later, those roles can be terminated automatically to save money during quieter periods, for example, at night. So this level of automation is ideal for the usage patterns discussed by Nick just a little bit earlier, such as predictable bursting and the on-off usage scenario. App Region also allows you to schedule backups of your SQL Azure databases and other Azure data. So it eliminates the need to initiate those manually. And App Region also makes application deployment and upgrades more efficient to Azure. So rather than having multiple developers performing upgrades, you might have one upgrading the SQL Azure database and another developer deploying changes to worker roles and web roles. App Region can simplify this by allowing the developers to deploy everything to App Region, and then App Region will perform the entire upgrade and deployments for you automatically, and this minimizes the amount of downtime that you might experience during the upgrade of your app on Azure. Several other functions that App Region can provide are access control and tenant management. And this allows customers and ISVs to manage multiple tenants and multiple developers on a single Azure billing subscription. It's also useful when you have multiple users administering multiple Azure subscriptions. Detailed operation logs are kept by App Region, and this can help with your security and operations governance. So to summarize with App Region, it's a tool that you can use to significantly increase your automation and functionality of Azure, as well as reducing the manual management overhead. So with this, tangible time and cost savings can be achieved. So let's provide a brief overview of a few of the tools that Fujitsu uses to make life a little bit easier to move to the cloud. I'd like to thank you for the time, and I'll hand over to Chris Gaskin, Solution Director and Global Lead for Legacy Modernization.
Thanks, Ken. So just have a slide here that I'll open up there. At the end of my slides, there'll be two demos, one for the access to SQL, and one is also the progression tool that we'll be talking about during my slides. Just wanted to start off with these two slides here, particularly paying attention to the Walmart one on the first section, which is the red line. Nick was discussing the concept of emergency and predictable styles of having a server farm. If you actually look at the one for Walmart, you see it's got an absolutely massive spike just before Christmas. Can you imagine if you're in a situation where you have to keep a server farm going for all that time? And is that predictable, or is that an emergency? Because if the farm was just a little bit lower than that and the whole thing collapsed, then you're looking at people like Target and the Barnes & Noble actually taking advantage of you. When you're actually talking about predictability over 1 year, how predictable is retail over 1 year? So again, very difficult to judge those. So that might be a really good example of where cloud and the cost savings could come into benefit. Just go click on the next button. So also what we're talking about when James was starting off this morning, we're talking about the various different things that we can actually move to the cloud. Obviously, you can't move absolutely everything, your entire application portfolio to the cloud. Some things are going to be better examples than others. So things that are more elastic, things that have SOA architecture, for instance. And I just wanted to go through some of the hurdles and opportunities that we've discovered that might help you discover really good candidates and to have a look at other ones and say, no, they're not going to go to the cloud. So the first one is scalability. This goes back in time. If you actually have applications that have been around for a while, you may find that some of them just don't scale. They weren't actually designed to scale in the first place. They were designed to run on one set of machines and one set of machines only. Moving them to the cloud, okay, they'll be on a different sort of vision separately, but you won't be able to put a lot of servers on. You won't be able to actually reduce the number of servers. They'll have to stay on the same number. In other words, a lot of the advantages of the cloud are actually going to be negated. So it might be that when you're actually looking at moving to the cloud, those won't be really good starting candidates for you. Second one is suitable technology. About in the 1990s, there are over 400 programming languages, a whole heap of databases and platforms that either aren't with us now, or you might call them either mothballed or sort of in decommission mode. Languages that have upgraded to some extent to the point where the earlier versions that your applications might be in just aren't available on the cloud. So there are several things that we could do about actually help migrate those applications to a point where they become suitable for the cloud, and I'll have an example of that later in my slides. Or it might be that you might say, actually, no, those are just not suitable candidates for the cloud, and we're going to keep them where they are. We'll use our own skills and staff and our own sort of technology platforms that we already exist in our own data centers. Next one is the thing about sovereignty and security. I know James has discussed security a little earlier, and we actually have a white paper that comes with this presentation, and I thoroughly recommend that you take advantage of actually downloading it. It's all about the cloud and security and goes into great amount of depth over that. One point of sovereignty, to some extent a lot of people say this is keeping things out of America from this sort of a Homeland Security Act and things like that, of actually making sure that the data and the applications that you keep in the cloud are actually kept in the cloud in your particular country. Now, we have an advantage in Australia here that there are clouds that are actually based here, that we can guarantee that anything information that actually stays in those clouds will never go outside the country, and will certainly not go to America, so that the NSA or whoever can actually have a look at it. So I think you'll find if you actually look at that, well, that security, I think James also mentioned this, security is actually not such an issue. People who actually run clouds, those data centers, they're very, very secure data centers. So obviously the security you actually get from them is going to be very, very high end. The fourth hurdle that you come across, I think this is the easiest of the lot personally. If you have an application that just isn't stable, but you may think is suitable for the cloud, but is actually collapsing maybe every week or every month, or maybe you don't have all the source for it, or a whole plethora of different reasons why you might consider it unstable. Moving it to the cloud isn't actually going to help. It might actually exacerbate the issue. I would have said that if you have an application that just isn't stable, it's probably better to either replace it, decommission it, mothball it, or fix it, instead of actually thinking of it as a candidate for the cloud. The next one is non-compliant databases and utilities. Now, if you're moving an application to the cloud, which is likely to be connected up to databases and to utilities, now some of those, the vendor, whoever that vendor might be, might not have the ability to move that database or those utilities into the cloud. It might be that they're just not cloud compliant, that they can't multi-tenant. So lots of reasons why they wouldn't be able to move to the cloud. The more of those that you actually have that are connected to an application, the more complicated and more difficult it's going to be to move the actual application itself to the cloud. Therefore, if you have a lot of those databases and a lot of those utilities, the less chance of that actually being a good candidate. The one that's basically stateful applications, which is the second to last one, in the old days when I was a programmer, and that's going back a little while, we used to have these things called stateful applications. And that's when you're doing a business transaction, you're hardwiring the database to the application to the front end. Therefore, if you lost the front end, basically you lost the whole business transaction. That's how things used to work in the past, but that's not how things can work on the web, and that's not how things can work in the cloud. The applications have to be stateless. Therefore, you have applications that have actually been built in a stateful manner, and we're talking about the older mainframe-style applications. Then as they are, they won't move to the cloud. They actually have to be altered. The architecture has to be changed in order for them to actually function properly on the cloud, because the user at the front end cannot be hardwired through a cloud, the database or the application. And finally, the last one of these is the extreme non-cloud integration. If you have an application that's integrated to lots of other applications, lots of other databases that may be on the cloud or maybe not on the cloud, all over the place basically, they may be client applications, we would suggest that they would be not necessarily the best candidates for you as a starting point to actually move to the cloud. It is easier to start with a nice simple application and move on from there. And that is why sometimes moving development and maintenance and into the cloud and to test in the cloud first to get your hands dirty with the cloud is often the best option. Moving on to the next slide, here we are. Just a couple of ways that we can actually assist you in working out what would be good applications to move to the cloud. Firstly, and I didn't actually put this in the slide, we actually have a network creeper. One of the things that people, when they come to us, talk about is that they don't actually know how many applications they have and where those applications live. This normally happens when you either have one or two IT departments from mergers, or you have user end communities that are actually allowed to write applications themselves, like access applications. So we can crawl around networks and actually find what the applications are. This will give you a chance to see what your actual application portfolio looks like. The next stage after that is to work out what the viable options are for any of those applications in the future. Now that might be they're fine where they are, or they might be decommissioned or replaced by a COTS package, or it might be that you can take advantage of the cloud partially, as in just moving the database or the front end, or taking the whole thing and moving to the cloud, be it a public cloud or private cloud. And that's called application value assessment. And it's a consulting-based option that Fujitsu have, and we come up with basic bubble charts and reports that will assist you in your business case to work out the viability of your entire application portfolio. Now, if you actually have applications that you think might be a good candidate for the cloud, but you don't know what sort of cloud and you don't know what sort of topology you might actually require when you're initially provisioning, we have a set of tools, actually two tools, both called Cloud Accelerator. One is a light, and one of them is a more consulting version. And for any particular application, we'll ask a selection of questions, about 19 questions about the application, and then a bit about sizing for the light version, and then 51 questions for the big version. And from those, we can actually work out which is the best cloud fit for you, public, private, Azure, for instance, and then also the topology, what the initial provisioning should be for those particular clouds. And that's an application by application option. So it really gives you a good chance to work out whether something is suitable for the cloud, and if so, what sort of cloud it would be suitable for. Now, my final slide before we get to that, just a demonstration of one of our offerings in global legacy modernization, which is the offerings I run from Fujitsu. This is our flagship offering, and basically it also talks about looking at those previous hurdles that we talked about on my second slide, how we would actually get around some of those. So, for instance, databases, if we wanted to move someone off of a mainframe, or a Unisys machine, or an HP 3000 or something like that, and you wanted to move it to SQL Azure, and the Azure platform, sort of cloud, then you would take the database, you could actually take database and flat files, and you can actually move those into SQL Azure. And there's a bit of an advantage there. Not only are you doing that, but we're also changing all the data access methods. And when we do that, more often than not, we find that there are some inefficiencies that have been built into the data access methods, and by fixing those on the way through such a migration, we can actually rapidly speed up your application's response times. Screens, we keep the screens as is, as in, if you have a green screen, it's going to be a web screen, but it's going to have the same fields in it, and will have the same as the older screen. And we often have situations where we're actually running this where the actual user staff need almost no training whatsoever, because they can see, yeah, okay, it's a new screen and it's to the new corporate standards and everything like that. But fundamentally, it's the same fields with the same validation doing the same work. Because when we do migrations, it's an as-is functionality. We do code analysis to make sure that the code is suitable, so we can retire any stuff that's made redundant or just not used anymore for other reasons. We turn that code into either Visual Basic or C#, or in fact netcobol for .NET if a client actually wants to retain the COBOL, and that will still work in Windows Azure. Things like JCL code or control language actually moves to the logic to VB or C# again, and we use PowerShell for that. And utilities are either replaced or altered as is required to make them work in Windows Azure as well. So in this case, you can see that we can actually take a mainframe. We change the architecture, so the stateful becomes stateless. The databases are now in the cloud, so there's less integration points. Any integration points with other applications stay exactly as is to make it easier to actually move from one to another. And with an as-is transformation, it's easy to test from one to another. And that's the example of moving from the mainframe to cloud, and we call that Fujitsu progression. Now, we've just got some demonstrations here. So, Chris, did I want to click one more button, or just stay there?
Let's go ahead and advance one more slide.
Okay, there we go.
This is a demo for converting Access databases to SQL Server. First, we start the One Nimbus 2 SQL tool and select the desired database, in this case Northwind. After analysis, 2SQL will perform a complete server-side migration of the database. After starting the process, 2SQL migrates all the objects to SQL Server, including queries and macros, and essentially replaces the Jet engine with SQL Server engine. Upon opening the SQL Management Studio, we can see the new Northwind database is being created. And once migration is complete, we have a copy of the Access database as a thin application which talks to the SQL Server. 2SQL has automatically wired up the thin Access front end to the SQL Server automatically and migrated all of our data. To demonstrate the connection, we'll change some data in Access and show it in SQL Server. We can now migrate our SQL Server database to SQL Azure. We can do this using the SQL Azure migration tools. First, we connect to the SQL Server and choose the database to migrate. We then generate SQL scripts and bulk data transfer files. Following this, we connect to our SQL Azure instance. And from within the migration tool, we can create a new blank database to receive the scripts and the data. Now we can execute the database creation scripts and bulk data copy against the new SQL Azure database. In the SQL Azure portal, we can refresh and we can see our added databases. And by viewing the details of the demo database, we can see the tables and the number of data rows that are being transferred. We can now proceed and link our Access front end to the SQL Azure database.
Hello, this is Fujitsu legacy modernization to the cloud using progression. First, I'd like to demo a transaction and a stream in the mainframe environment. Using an emulator, the transaction is typed into the stream of the mainframe. In this case, this is a vehicle name inquiry with the last name Smith. Record of fetch presented to the user, and using a cursor, the user selects the proper record and the record is displayed. The user can press enter and see the next stage, position at the end, press enter again, and the page is shown again. Now I'd like to convert some COBOL program to C# using progression. This is the main concept of progression, where the legacy code is converted using the code modernization module into C#. The result can be deployed into .NET or Azure or any cloud platform. The conversion starts with Fujitsu progression tool, which executes the conversion of the COBOL to C#. In this case, I will open a project already set up for COBOL to C#. Those are all the modules. I'm going to select the business logic, which converts COBOL to C#. In this case, I'll select one COBOL. Here's the setup for the substitution, conversion, and dictionary. Everything is parsed into an XML file, and the C# is generated from that XML file automatically. Here we're done. Now let's look into Visual Studio, a side-by-side compare of the resulting C# I'm showing now. Every piece has a region. This one is the region of the comments. As you can see, they're all kept. Another region, very important, is the business logic itself, the main program, which will be the procedure division into a COBOL program. As shown here, you can see that all the code is converted as is, all the business logic is preserved from the COBOL into C#. If I scroll down, you'll see there's also a paragraph that becomes method, and call program that becomes just a start program. Now let's show a modernized transaction in a stream deployed into the cloud. In this case, it will be Microsoft Azure. I'll first go into the Azure platform. I have already deployed everything. So you can see here as my progression demo. This is the progression demo using a small setup. Everything has been deployed, so it requires also web role. Database has been deployed into SQL Azure. Now let's click the link of the progression streams running into Azure. Same query, vehicle name query with SNP. As you can see, the look and feel remain exactly the same. Now the data is fetched to SQL Azure. I can click on the first VPI, and the same screen pop up. You can see exactly the same look and feel. I don't have to position my cursor for getting the next and the previous screens.
Hi, it's Chris back here again. Okay, so last slide before questions. We have a link up here so that we can either just a cloud workload assessment with yourselves. Also, we could be looking at proof of concepts regarding velocity or progression. Velocity was the one that Ken was talking about. And of course, I was talking about these free white books, the one about cloud adoption and cloud security, which I thoroughly recommend. So with that in mind, I'll just click the next one. We go to the questions and answer session. I'll pass it back to Chris.
Thank you very much, ladies and gentlemen. We are opening up the floor for Q&A. If you have a question, please do type your question into the field and then click Ask by clicking the Q&A button and drop down over here. Then type your question into the field. As a reminder, you can print a copy of today's presentation by clicking on the printer icon located in the bottom right-hand corner of the client. And then you can also download a copy of today's PowerPoint presentation by clicking on the handout section. This is located in the upper right-hand corner of the client, indicated by an icon that looks like 3 white sheets of paper stacked on top of each other. I also want to call out that we do have a survey. Please do take some time to fill out our survey, as your feedback is very important to us, and we do incorporate it into future presentations. With that, I do want to go ahead and start with our Q&A. I know our time is short, so we have a question from one of our attendees. I have heard that once on a cloud, it is difficult to move to another cloud. Can anybody comment on that?
Hi, this is Ken. I can take that. So knowing how to move off of cloud platforms is just as important as knowing how to get onto a cloud platform. It's just one of the aspects that you've got to take into consideration right at the beginning when you're choosing your cloud platform. You basically need to confirm that your choice of cloud provider allows future portability, because many of the current cloud providers have bespoke code requirements or APIs that you have to incorporate into your application developments. Just going to make it more difficult to move on to another platform at a later point. Another thing to consider is data. But if you're storing your data in the cloud, how do you get back? What is your cloud provider going to provide to allow you to get your data download back to your on-premise? Who really owns it and who has access to it? So they're just sort of some of the key things to take into account when you're choosing a cloud provider and being able to move later to another cloud provider. I hope that answers the question.
I think that's great, Ken. Thanks so much. I'm very conscious of time and that we've gone a couple of minutes past 10 o'clock. I want to ask, firstly, thank all the presenters for their time today, and in particular, thank all of the attendees. We greatly appreciate it. Hopefully, you've got a lot out of the call today. There will be a PDF of this available, and I don't know if Chris was going to talk further about that now. Chris?
Ladies and gentlemen, as a reminder, you can print a copy of today's presentation by clicking on the printer icon located in the bottom right-hand corner of the client. This will print out a PDF copy of today's slides. As a reminder, we are also recording this session. A recording will be made available within approximately 48 hours post-event via a link. And you can download a physical copy of today's PowerPoint, which has been uploaded into the handout section located in the upper right-hand corner of the client.
Fantastic. Well, I think that wraps up the webinar today. Thank you so much again to all the presenters and to everyone for listening to the call.
And thank you. I want to thank all of our presenters for presenting today's material, and I want to thank you for attending today's presentation. If you haven't already, please do leave some feedback on how you thought today's presentation went. We do incorporate it into future presentations. Ladies and gentlemen, this does conclude our presentation for today. You may now disconnect.